Video 41 show that there exists x p of x and q of x implies there exists x p of x and there exists x q of x. Prove that the converse is not true. Now on the left side, this x is common for both p and q here, but here on the right hand side, this x may be different from that element. Here there may be one a for which p of a is true. Here there may be one b for which q of b is true. But on the left side there must be one a for which p of x is also true and q of x is also true. So here common value of x. Here the value of x, it may be different from the value of x here. That is the difference. So proof, premise, there exists x p of x and q of x. Conclusion is the right hand side. So we take steps and reasons. First step, we will take the premise. So there exists x which is common for both p and q. Therefore p of a and q of a for some a. This a and this a, they are equal. So this is called existential specification. From x we go to a means existential because there exists specification. So p of a and q of a for some a means p of a for some a and q of a for same a. For same a, the both are true. So the first one implies there exists ax p of x and q of a means there exists ax q of x. This is existential generalization. So this implies there exists x p of x and there exists x q of x. So this is conjunction from 4. So this completes the right hand side and therefore the proof is over. Now what you need to prove is converse is not true. Converse is not true. For that we have to give a counter example. For that we take let the domain of discourse, that is domain over which x varies, the domain of discourse be the set of all integers. The set of all integers. Let p of x be the statement x is odd. Q of x be the statement x is even. So then p of 1 is true and q of 2 is also true, because 1 is an odd integer, 2 is an odd integer. So therefore there exists x p of x because there is one integer which is odd, and there exists x q of x. So which implies there exists x p of x and there exists x q of x. So that is the right hand side is true. Now what we need to prove is the left hand side is not true. What about the left hand side? The left hand side is there exists a common x satisfying both conditions. There exists no integer which is both even and odd. That is, there is no x such that p of x and q of x, same x satisfying both, not possible, which implies there exists x, p of x and q of x, that x is a common integer is not true. Is not true. Therefore, the converse is not true. Therefore, the converse part is not true. So, since the converse is not true, they are not logically equivalent. One way it is true, the other way it is not true. This completes video 41.